Hi, this is Jason Baker, and welcome to our weekly lecture on DevOps and Cloud Infrastructure. This week, we're going to talk about many of the additional services that are available in AWS, what I call the AWS extras. Now, these aren't services that you'll necessarily use every day, but it's likely that if you build out future applications and platforms in AWS that you'll encounter many of these services. And even if you never use a particular service, I just want you to be aware of what the service does so that if you see other people in your organization using these services, you have some understanding of the features and capabilities that are available to you within the AWS ecosystem. Okay, let's get started. Let's take a quick look at the agenda for the lecture. And here's the list of the AWS services we'll look at during this lecture. We'll look at CloudWatch, which we use for monitoring services. We'll look at something called EC2 User Data. We'll look at EC2 Auto Scaling, which allows us to elastically build compute infrastructure, Elasticache, SNS, the simple notification service, SQS, the simple queue service, the simple email service, Route 53, which is a DNS hosting service, Elastic Beanstalk, which is Amazon's version of platform as a service. And then I'll wrap up the lecture talking a little bit about AWS security. Okay, let's jump into our first AWS service, CloudWatch. So CloudWatch is a monitoring service that we can use to sort of view the performance and health of AWS resources. It allows us to track performance metrics on services. It allows us to collect and monitor log files that might be generated by services. And you got to realize that basically every single AWS service and resource that you create is generating some metrics and some log data. And we can use those metrics and log data to really analyze and understand the performance and health of our infrastructure over time. And this information is absolutely critical, especially in an operational setting, because if there are some sort of problems with your application platform, you're trying to you're trying to figure out and troubleshoot where those problems are coming from. Is it something with your application code? Is it a problem with the configuration of your operating system? Is it an issue where you don't have enough compute or memory or storage IO to support your application? Or is it there's some sort of networking issue? Is there a networking issue between your Elastic load balancer and your fleet of web servers? The CloudWatch metrics can give you insights as to what is actually going on in your platform and in your infrastructure. When you're working with CloudWatch, you can set up alarms, and you can base these alarms on sort of predefined thresholds that you set up within your environment. For example, you could set up an alarm based on the CPU utilization on your EC2 instances. You could set up an alarm based upon the storage IO utilization on your database system. And if if the utilization of a particular a resource like CPU or storage IO, if that goes over a certain threshold, then CloudWatch can generate an alarm. That alarm might send an email message to you, or it might send something like a text message to your phone. That alarm could also trigger some other action. So, for example, we'll learn about auto scaling later on in the lecture, but perhaps Like if you have a fleet of servers and the CPU utilization goes above a predefined threshold on those systems, perhaps that would automatically trigger the launching of additional EC2 instances to expand, to horizontally scale the pool of computing resources available to your application. The CloudWatch service is available in most every service within AWS. So if you look at your EC2 instances or RDS instances, things like your DynamoDB databases and many other services, you'll see that each one of these services has CloudWatch metrics available. And if you look at something like your EC2 instance, there will actually be if you click on the instance in the AWS dashboard, you'll see that there's actually a a tab panel that shows you all kinds of metrics related to that EC2 instance. Those metrics are being collected and instrumented and displayed by the CloudWatch service. Now, when you use these AWS services, CloudWatch is automatically enabled for free with what's called a basic monitoring capability. It's possible with many services to enable detailed monitoring for the service. And when you enable detailed monitoring, what that basically does is it increases the granularity of CloudWatch metrics. CloudWatch is basically polling the service on a frequent basis, and it's pulling metric from information from that service, and then those metrics are available for display to you. The basic service, CloudWatch is polling each AWS service approximately every 5 minutes. And if you enable detailed monitoring, then CloudWatch will poll the services for metrics every minute. And that might not seem like a big difference, but it actually is a substantial increase in the granularity of the metrics that you're collecting, and especially like in a production environment, that greater level of granularity can be really important. One thing I should note is that you're not going to just use CloudWatch in a production environment. You'll also use this in development environments. You might have an environment where you're doing performance testing. And in that sort of environment, CloudWatch is very, very convenient because the metrics that it produces can help you analyze your platform and infrastructure architecture and help you sort of optimize the resources that you're configuring for your particular platform. Here's an example of CloudWatch instrumentation, and I mentioned that if you go to many of the different AWS service dashboards, you'll see panels available like this for each particular service where you can see things like the average CPU utilization and the storage. You might see this is for a database service, I believe, on RDS instance. You'll see things like average write, I/O. You'll see things like network latency and so on. And again, these metrics are absolutely critically important to us in trying to understand how our software, how our application is actually performing within AWS infrastructure. So that was CloudWatch. We use CloudWatch for monitoring purposes. The next service I'll talk about is CloudTrail. And one thing I should note is that some of these service names sound very similar because they start with cloud. They're cloud something. CloudWatch, CloudTrail. So uh, try not to get confused. I think that you just have to sort of like try to memorize what these names mean and what what features they provide, because there's a whole list of them and it can kind of get confusing. So CloudTrail is a service that basically allows us to audit all of the AWS API calls that are made within our AWS account. And so why would you want to audit your API calls? Well, auditing is really important because it allows us to track and report on all of the sort of activity within our AWS account. And we might need to provide that auditing for perhaps for compliance purposes. It can be very helpful for troubleshooting purposes. If you have a number of people within your organization and maybe they're making changes to AWS resources. Maybe you have applications which are making changes to AWS resources via the AWS API. It would be really nice to have a record and a history of all of those different API calls. I was working with an organization at one time where they had a security breach. They actually had essentially someone hack into their AWS account using an API key that a developer inadvertently published to an internet website, a public website. And thankfully, we had CloudTrail enabled in that AWS account because we were able to look at CloudTrail and all the audit logs to see exactly what that hacker was doing in that AWS account, and it greatly helped us uh, sort of mitigate that issue and solve the security problem. And it also allowed us to see kind of what that person was doing, so that we knew what resources were impacted by that breach. The way CloudTrail works is that you enable CloudTrail within your account, and CloudTrail creates basically a stream of log data, which is written to something called a trail. And basically, a trail is a set of log files, log data, that is written to files within a designated S3 bucket. And what's kind of cool about CloudTrail is that you can set it up to be very specific so that it will contain logs just from one region within your account, or you can have it audit all of the activity across all of the different regions within your account. And you can set it up to be sort of fairly granular if you want to just audit certain things, and so there's a lot of flexibility with the service. Generally, the way I set it up is that I set it up to audit and record all activity within a particular region, because I just want to see everything that's happening. There is, of course, a cost, a small cost to setting up CloudTrail, and you pay for the S3 storage and the logs that are being generated, but it's a very, very small cost, and the whole scope of things. I think CloudTrail is one of those services, especially if you're using it in a business setting for your organization. I think it's an absolutely essential service to set up. Okay, the next service is AWS Cloud or AWS Config, and AWS Config is a service that allows us to define configuration policies for our AWS resources. And what AWS will do is AWS will basically scan our resources and compare the configuration of those resources against our policy. We can also use AWS Config to sort of generate a report on the configuration of all of our resources within our account. So AWS Config can be used for reporting and auditing purposes. It kind of lets us generate a document which describes how all of our different AWS resources are configured, and it provides it in a very nice, succinct summary document. But again, we can also use it to compare our resource configuration against a sort of known policy. And that allows us to use this for compliance purposes. A simple example is that our organization might require that all of our EBS volumes are encrypted. Maybe we're storing personal health information and other very sensitive information. So we want all of our EBS volumes. Remember, these are the virtual hard drives that are attached to our EC2 instances. We want all of the data on those volumes to be encrypted at rest. That's part of our corporate-wide compliance policy. And we can use AWS Config to scan all of our EC2 instances and our EBS volumes and validate that those volumes are conforming with our required policy. And so very, very helpful service. For those companies who deal with these compliance issues, they need a way to ensure that the resources are continuously complying with the policy. The AWS Config service, it generates reports on a scheduled basis, and it can store these reports in an S3 bucket for you. And one of the cool things about the service is that if it sees some sort of change in a resource configuration, or if it sees a resource that does not comply with a policy any longer, then it can generate a notification. And just like CloudWatch, that notification you can send it to your email, or can send it to as a text message, and so on. Okay. The next item here is not really a service. This is a feature that's available to us as part of our EC2 service, and it's called EC2 User Data. It's an extremely useful feature, and one that I use all the time. In fact, I can't remember the last time I actually didn't use it when I was launching an EC2 instance. EC2 User Data is basically a shell script that you can set up to automatically execute when an instance launches the first time. You can think of this as an initial bootstrapping script. This is a shell script that you want to run the first time your instance launches. And generally, this bootstrapping script is used to initiate further configuration of your new EC2 instance. So for perhaps your EC2 instance launches and you want to update the software on that instance, you want to install your Nginx web server, and you want to download your website files onto that instance. You could use the EC2 user data script to completely bootstrap and build your instance. The shell script commands are provided as part of the EC2 instance configuration, and I'll show you real quick where that happens. I've already logged into the AWS console, and I'll click on the EC2 dashboard, and I'll go ahead and begin the process of launching a new instance. So select the Amazon Linux AMI, T2 Micro, click Instance Details, and this, of course, is where we can set things like our subnet, and we can specify the VPC that we're going to use, and so on. You may not have noticed this little advanced details section because it's normally collapsed, but if I expand this section, then it shows this user data field. And in this user data field, I can type in a shell script. And so I can type in a shell script that does anything I want it to do. So I could do like I could do a yum update here, and I could do a yum install nginx here. When the EC2 instance launches for the first time, the very first thing that instance will do is run this shell script that's defined as part of the user data. When it runs this shell script, it runs it as the root user. So I don't need to do anything like, there's no need to prefix these commands with the sudo command. That's totally unnecessary because this script is run by the root user. So this is just an incredibly helpful feature that allows us to bootstrap a system when it launches that first time. Here's a screenshot I had included in the presentation that again just shows you where we can enter in that user data. And in this case, this is a set of environment variables that are being set and that are being passed into that EC2 instance. Maybe we've already created a special AMI, and our AMI already has all the software we need baked into the image. When we launch that image, we can maybe perhaps pass in a set of variable parameters, and those variable parameters would automatically configure that software running on the image for us. So that's another way you might use user data. You have this image that's already pre-configured with all your software on it, but when that instance launches the first time, you want to pass in some parameters to specifically define how that software is going to run on this particular instance. User data allows us to do that. Okay. So the next service I want to talk about is EC2 Auto Scaling. And EC2 Auto Scaling is a really amazing service. It allows us to elastically scale the compute capacity within our platform. It allows us to scale EC2 instances up or down based on a set of defined conditions. We can use auto scaling a couple different ways. One way we can use auto scaling is that we can specify that we want a certain number of EC2 instances to run at all times. Let's say we want 3 EC2 instances running at all times within our VPC. If one of those instances were to fail for some reason, maybe that instance was running in an availability zone which failed, maybe the instance was running on a physical server which failed. When that instance fails, there's only 2 instances left running. The auto scaling service will recognize that state, and it will automatically spin up another EC2 instance to take the place of the instance which failed. We can also configure auto scaling to monitor the current demand on our service. And so, for example, if we have this web service or web application, and during the course of the day, there's more and more customers who are accessing our web application, the auto scaling group could the auto scaling service could automatically recognize the increased demand on our web application platform and then spin up and increase the number of EC2 instances to horizontally scale out our web application to support that greater demand, that increased number of customers. And then conversely, as our service experiences less demand, maybe like late in the evening or something, and there's far fewer customers accessing our web application, the auto scaling service can automatically terminate some of the EC2 instances and reduce the amount of compute that we have deployed in order to save costs. The auto scaling service itself is free. You don't pay anything for this this really awesome capability. You only pay for the resources that it creates. You don't actually pay for the auto scaling service itself. When you're configuring the auto scaling service, there are two different components that you need to create. The first configuration you need to create is what's called the launch configuration. And the launch configuration basically specifies the type of EC2 instance that you want the auto scaling group to create during an auto scaling process. The launch configuration is very, very similar to the process that you go through when you're defining and launching a new EC2 instance. When you create the launch configuration, you're not actually launching an EC2 instance. You're just defining what the configuration of the EC2 instance is going to look like. The second component to the auto scaling service is the auto scaling group. And the auto scaling group basically defines the set of EC2 instances that you want created within the group and the conditions upon which the auto scaling group is going to initiate the auto scaling processes. There are basically three different ways that you can set up the auto scaling group configuration. You can set up a configuration to maintain a minimum number of instances at all times. And that's the scenario that I talked about earlier, where you configure within the auto scaling group that you want 3 instances running at all times. And the auto scaling group will create new instances if it sees an existing instance become unhealthy and fail. A second way that you can use and configure auto scaling groups is by manually scaling the group. For example, you can set up the auto scaling group so that it initially has, let's say, 3 EC2 instances. You can then, at a later point in time, reconfigure the auto scaling group and bump the number of EC2 instances up to 6, effectively doubling the amount of compute power that you have deployed. When you change the number from 3 to 6, the auto scaling service will automatically launch 3 additional EC2 instances for you into the account. And then finally, the third way to work with auto scaling groups is to set up dynamic scaling. And what that means is that the auto scaling group can automatically increase the number of EC2 instances or decrease the number of EC2 instances based upon some sort of CloudWatch metric and CloudWatch alarm that's being generated. For example, you can set up a CloudWatch alarm which is based upon the CPU threshold of your EC2 instances. And if the CPU threshold on the instances goes above, a certain percentage, CPU percentage, then the auto scaling service will automatically launch more EC2 instances. The idea is that these instances are probably located behind an elastic load balancer, and that elastic load balancer will then distribute requests across a larger pool of EC2 instances. Okay, well, like many of these other services, the best way to learn how to use auto scaling is to work with it hands-on. And so let's jump back over to the EC2 dashboard, and we'll create an auto scaling configuration. So the first step is to create what's called the launch configuration. Now, I'm in the EC2 dashboard, and that's where you'll find the auto scaling service. I look under auto scaling and you see launch configurations. Go ahead and click on the launch configurations link. And we're going to click on the create launch configuration button. We'll go ahead and create a launch configuration. Now remember, creating a launch configuration is just like setting up and launching an EC2 instance. But in this case, we're just creating the configuration. We're not actually going to launch an EC2 instance at this point. We'll start by selecting our AMI. I'll pick the Amazon Linux AMI. And we'll launch a T2 Micro. We're going to give this launch configuration a name, and we'll just call this like my demo config. We can assign IAM roles to it here if we want to. Remember I talked about CloudWatch monitoring earlier. We get basic level of monitoring. If I want to enable detailed monitoring, then I could check this box. If I click on advanced details, then I can, here I can specify my user data if I want to. I can add storage. I'm just going to keep my existing 8 gigabyte storage volume. Configure a security group. Just like creating or associating our EC2 instances during launch time, we do the same thing when we create a launch configuration. In this case, I'm just gonna leave it at this automatically generated security group. Click on review. Everything looks good. The next step is to create the launch configuration, and this wizard process leads me right into the launch. You'll see is going to lead me into the creating the auto scaling group. So I need to select a key pair that I'm going to use. I'm going to use the existing key pair. Acknowledge that I have access to it. Create launch configuration. Okay. So now it's created the launch configuration, and I want to create an auto scaling group using this particular launch configuration. So I'll just continue to create the auto scaling group. I'm going to give the auto scaling group a name, and I'm just going to call it, let's say, I'm going to say my server ASG, stands for auto scaling group. And the group size I want it to start, let's say with 3 instances. It's going to ask me which VPC I want to launch it into. I'm just going to use the default one for now. If I click on advanced details, this is where I could set up and connect the auto scaling group to a load balancer. So for example, if I had a load balancer I had already set up, I could associate this auto scaling group with that load balancer. And the really cool thing about that is that when the auto scaling group adds or removes new EC2 instances, those instances will automatically be associated with the Elastic Load Balancer. I don't need to go and modify that load balancer. It's all tied together. It's all completely integrated together by AWS. Okay, this all looks fine. I can configure at this point. I need to select a subnet. I'll just select the first subnet that's available. I could select multiple subnets here if I wanted to. If I wanted to distribute the instances across multiple subnets, I'll just do that for the heck of it here and select a couple different subnets. Okay, it says select scaling policies. Remember I talked about some of the different ways we can configure the auto scaling group. I'm just going to use the first policy, which is the simplest policy. I want the auto scaling service to keep my auto scaling group at this particular size, this initial size. I'll go ahead and I can click on the configure notifications. I'm not going to add a notification to auto scaling group at this point, but we'll learn more about notifications here later in the lecture. I could set up a notification to send me an email message every single time there's an auto scaling event, every time there's a new EC2 instance added or removed. There's some sort of policy change. I can add tags. I can add a tag. And this is again our meta tag that's associated with the auto scaling group. I'm going to call this project, and I'm just going to call it Project Fido. Whatever I want. I can add whatever metadata I want to this particular auto scaling group. And the auto scaling group itself is a resource. It's not like an EC2 instance, but it's defining a configuration. And so we would also want to tag this resource that we're creating. I click on the review button and I go ahead and create the auto scaling group. Now, when I do that, I'm going to go back to the EC2 dashboard and let's see what's happening. I'll click on my instances here and click on refresh, and you can see that AWS is automatically spinning up 3 new instances for me. And it's creating these instances based upon my launch configuration that I set up. I'm going to maybe, oh, it looks like these instances are at least running state, they're initializing. I'm just going to pause the video for a minute while these complete their startup. Okay, a couple minutes have passed and all of our EC2 instances are running, all of our status checks have passed. And at this point, all of the instances are healthy. What I want to do is try to simulate the failure of one of the instances. And for example, let's pretend that like one of the availability zones has failed. One thing you should notice is that these instances were created across multiple availability zones. When you associate multiple subnets with the auto scaling group, and those subnets are spread across different availability zones, then the auto scaling group will try to distribute your EC2 instances across those different subnets for you automatically. Let's take this third EC2 instance and we'll go ahead and terminate it. This will simulate a failure of that instance. You can see that the instance is now shutting down, and it's going to take maybe up to a minute here for the auto scaling group to recognize that the instance has failed. So I'll click on the refresh button here. Still shutting down. Remember, you would typically have these instances associated with an elastic load balancer, and the elastic load balancer would quickly realize that the instance was no longer available. And by this point, it had already redirected requests to the other two instances, which are still healthy. So this instance has terminated. And we'll just wait another minute here for the auto scaling group to fire up a new instance for us. If we look at the auto scaling groups, you can see that our desired configuration is 3, maximum is 3, and the number of instances that are currently running are just 2. Oh, there we go. So there's our new instance, which was fired up. It's still in the initializing phase for its status checks. But the auto scaling group recognized that there were only 2 instances running. Our desired state was that we wanted 3 instances to be running. And so this auto scaling group service automatically has launched a new instance for us. Its purpose in life is to always try to maintain our desired state, which is we configured the auto scaling group to maintain 3 running instances at all times. If we were to terminate all 3 of these instances, then the auto scaling group would just spin up 3 new ones. So it'll keep creating these instances to ensure our desired state is met. If we wanted to shut down all of these instances, then what we could do is go into the auto scaling group and go to our configuration, select our auto scaling group, click on edit, and here we can go and edit the parameters in our auto scaling group configuration. Our desired, and we could set like our desired to 0, minimum to 0, and maximum to 0. And then save that. So we set all of these parameters to 0. We go back to instances. These are all currently running. But now you see auto scaling group service is shutting all of these instances down now, because my desired state is that I want 0 instances running. So that's the auto scaling group service. A really useful service, an important service. It's a feature that I use all the time. In fact, there's a case to be made that even if you are just running a single instance, you might want to set up that instance using an auto scaling group. For example, you might have, like, even if it's just like a single web server, you might want to configure AWS so that if that web server, that EC2 instance supporting the web server, if that fails, then EC2 will automatically spin up a brand new web server for you, perhaps in a different availability zone. So you would set up an auto scaling group with a desired size of 1 instance, minimum and max size of 1, and the auto scaling service will always ensure you have at least one EC2 instance running. So it can be very, very useful even for just keeping and ensuring that one single EC2 instance is running at all times, supporting whatever application workload you need to run on it.